So then the distributive property, we've got to make sure we multiply everything. If this is subtraction, then this is subtraction here, right? So we're going to utilize that in solving the equation. So here they talk about, in example 2, they talk about a baseball card that's worth a lot of money. And Darius has he has $500 to spend on baseball card at a baseball card convention. So he decides to spend all his money buying the rookie cards of his 2 favorite players. And at the end of the season, he finds the first card increased in value by 21%, and the second card decreased by 7%. So he spends D dollars on the first card, so we're not saying how much he spends. So that means that he spends 500, subtract those D dollars on the second card. So we're assuming he spends all $500. So what they do is they write a function here where T of D is equal to 1.21 times D. So this card increases in value by 21%. Therefore, at the end of the season, the card is worth 121% of its initial value. So that's where the 1.21 comes from. And then the other card, because it decreases in value, we multiply the value of that card by the amount that it decreases, subtracted from 100%. So it goes down 7%. So now it's only worth 93% of the original value. And if we take that 93% written as a decimal, 0.93, we multiply it by, what is it, 500, subtract the other card's price. So this is the relationship between the values of the cards. So this is the total value of the cards at the end of the season. So what we're going to do is we're going to use this to determine how much he spent on each of the cards. So if he has $500 to spend on the cards, we got 21%, we got 7%. And then at the end of the season, it's said that this is all worth, his cards are worth $550. And T of D is equal to 550. And 550 is equal to this value. So now what we have is we have an equation well, we have a single variable, but it's written twice. We have to be able to combine that variable together as like terms and solve for them. But the variable here is inside a parentheses, so we have to remove the parentheses really before we can do any work. So we've got to use the distributive property. So we have 550 and then this is subtraction, so 0.93 times B. Now we have like terms here and here. We have multiplication here. So 1.21 subtract 0.93 is going to be how much? What's 121 subtract 93? 28. So this is going to be 28 hundredths D. And then 0.93 times 500. Well, this, when you distribute here, then this becomes a negative 0.932. I'm sorry, 0.93D. So this value here, that's a negative. This is a positive. So when you put those together, you only end up with 0.28 times D.
So that's not, you wanted to get rid of this 0.93, so you add 0.93. Oh, I see. It's not on the other side of the equals. So,
Yeah, we're still on one side of the equal sign here. So when we bring this across, if you wanted to, you could call that the addition of a negative, then this would be the addition of a negative. Then, those two get put together, you have 28 hundredths times d. So what's 0.93 times 500? I can't hear you up here with all these sounds. 465, thanks. 465, and then we're going to do what? Subtract it. And then we have 28 hundredths d is going to be equal to 85. Divide, yep. Somebody have a card or a division for me? What is that? 330? 303. 56? Okay. 303.57. So that's what the one card was. And then the 500 subtract b. So then it would be 500 subtract 303.57 is the other card. I'm just going to write it. But so now we know what he spent on the cards. About about 303 and about 197 on the other card. Okay. You guys remember multiplying through to clear fractions and decimals? Remember doing some of that kind of work? I know that it was a struggle at times, and I pushed it really hard. This year, we have to embrace it. As challenging as it has been. So, this problem here, this comes from the number of points that are scored. In Game 5 of the 2006 NBA Finals between Miami and Dallas, they say Dirk Nowitzki scored a fifth of Dallas's points, Josh Howard scored a fourth, and the rest of the Mavericks scored a total of 55 points. So how many points did Dallas score? So if we say that P is equal to the number of points, the total number of points, then what we have is 1/5 of the points by one player, 1/4 of the points by another, and then 55 remaining points by the remaining members of the team. And what we want to do is we want to figure out how much each of these players scored. And we can also figure out from this how many points were scored in the game. So the first thing that we need to do with this, we can put all of these points together here and then subtract and what have you, that's fine. But if you want to stay away from working with fractions, which we do, we can multiply this entire equation by what value? I heard a sound.
20.
By 20, yeah. And it's 20 because that's the least common multiple of 5 and 4. And if we do that, if we multiply everything by 20 and bring it across, we multiply 20 through both sides of the equal sign. And now 20p is equal to 20 times a fifth p plus 20 times a fourth of p. Don't forget to take 20 times the 55, each and every term. And the idea here is that 20 divided by 5 is equal to 4. We're simplifying. And 20 divided by 4 is equal to 5. And now we're just making it so we have whole numbers, which can be a little bit neater and a little bit cleaner. So here's 4p and 5p. So that's 9. And if we use inverse operations, we can subtract 9p from both sides. This all zero cancels. So 11p is going to be equal to 20 times 55, which is going to be Well, 2 times 55 is 110. And then we multiply by 10 again. We've got 1100. So the number of points is equal to 100. Yeah. So if you need to divide by 11 to show that, fine. You don't have to. Then they give the opposite of a thumb, or the opposite of a sum theorem. And it's something that we've practiced in the past when we've seen 2 years, but now we give it a name such as a theorem. And essentially it's this. If we have a sum of terms, and we think of that as being in parentheses, if we take the opposite of that value, that is the same as taking a -1 and distributing it across the sum. So then you get a -1a, or simply -a, plus -1b, which is -b. So this is important. And so this can be challenging to get through once we see it in different problems. But when there's a negative in front, this is going to change the sign of everything that's inside of here. So if you had something like x minus y, and you wanted to take the opposite of that value because you see that's being subtracted, for example, in some equation, this is going to turn into a negative times the x plus a negative, which is a positive. So this is what it does. When there's negative signs inside the parentheses, and then there's a negative outside of the parentheses, sometimes students have difficulty with that in the context of a bigger problem. So be really conscious of it. Love to see you guys get through this one real quickly, because it saves a lot of grief in solving problems later on. So here's an example of its use. So in example 4, they give function g of a. And g of a is equal to 3a minus, and we read this, the quantity of 7 subtract 5a. And then they ask for what value of a is g of a equal to. So if this is equal to 12, now we got to figure out the variable a. And we just substitute the 12 in. Now, we think of it this way. We have to subtract this entire quantity. So we have to subtract the 7, and we have to subtract a negative 5a. Now, I suggest that for a while at least, like maybe for a long time, maybe for years even, whenever you see subtraction inside of parentheses and you know you have to work with it, rewrite it as the addition of a negative. It makes it so much easier to keep track of negatives. Plus, you can change the order if it's addition of something. If it's subtraction, you gotta be careful about moving terms and changing the order. You can make mistakes easily. But if we do this right here, now when we distribute that negative across, it's a little bit easier to keep track of. So 12 becomes 3a. You might also think of this as -1 multiplied by this. So you have a negative times 7, which is a -7, and then a negative times a negative, which is a positive. So the negative 5a, or subtraction of 5a, becomes the addition of 5a. Now the parentheses are gone. And if we keep everything written then in terms of addition, we look back at that 7 and call that the addition of a -7. Now we can add in any order we wish. So there's 3a and 5a, which is 8a, plus a negative 7. And then we can cancel out the negative 7 by adding 7. Now we have 19 is 8a. Do the division. And then a is equal to 19/8. Leave things as fractions, unless the question is asking for a number that makes sense to be written as a decimal. But for graphing purposes, or just solving numerical problems, leave things as fractions. And they're not telling us what the function g is, so just go with it as it is.